Hello everyone, this is Team Bias. The name of our app is SkinLens, your personal dermatologist. We came up with the name Bias as it is a very common error in machine learning likely to occur at any stage, and it also has a playful ring to it. Next slide. So the entire project was carried out in 4 sprints, 0, 1, 2, and 3. This presentation is at the end of the final sprint, that is sprint 3. Let's look at the agenda of this presentation. So first we are going to go through roles, responsibilities, and improvements from the feedback. Then we are going through problem statement, project description, working agreement, then personas, MVP, project design using Figma, and we are going to discuss the technologies, algorithms that were used in developing the app, as well as the diagrams, and then we are going to quickly go through the entire product backlog as well as sprint 1 and sprint 2 summary. Then we are going to discuss specifically related to this sprint, that is sprint 3 user stories, test cases, and the stories we were able to complete and the stories we were not able to complete. And then we are going to discuss about the sprint 3 metrics, that is velocity, burn down chart, committed ratio, as well as we are going to talk about the historical velocity and historical committed ratio. And at the final part, we are going to discuss about the sprint 3 retrospective, so that we improve our team's performance in the next sprints. And as well as after this, we are going to quickly go through the APIs that were crucial in building our app. And then we will have a quick demo at the end of the presentation. Next slide. I am Mohammad Zaid, team leader and developer.
Hello everyone, my name is Joan Yin. I'm developer and also I'm the Scrum Master.
Hello everyone, myself Naganjali Pujita. I'm a database administrator and developer.
Hi everyone, myself Mohammad Tanzil Bilal. I'm a developer and a tester.
Hi guys, I'm Bang Yin. I'm a developer.
Hello everyone, my name is Abhikumar Patel. I am the developer and the tester.
So these are the improvements that we made. That is, we have included historical velocity chart as well as committed ratio. And the technical story one, what we had, it was to write user stories and acceptance criteria. But as it is a recursive task, we removed it from the backlog. Next slide. So let's dive into our project. What are we solving? Let's start by understanding the problem we are solving. Accurate and timely diagnosis of skin disease is a challenge faced by many people. Now, one of the main reasons for this is limited availability of dermatologists, especially in remote or rural areas where access to specialized care is very difficult. Now, in such places, people often have to wait a long time or travel far to see a dermatologist. And even when dermatologists are available, traditional methods rely heavily on visual inspection of the skin. Now, while this is a very common practice, it comes with its own issues. Human judgment can vary and mistakes might happen due to how the condition is interpreted. Now, this creates inconsistencies and can result in less effective care. Now, what does this really affect? It leads to delay in diagnosis, meaning people don't get treated on time. This also means patients receive less personalized care, which can make them feel neglected or frustrated. Worse still, if skin diseases are not diagnosed or treated quickly, they might become more severe, impacting the person's overall well being and quality of life. Clearly, this is a problem that needs a better solution. Next slide. Now, let me introduce our project, that is SkinLens. SkinLens is a web-based platform designed to help patients diagnose their skin conditions using advanced deep learning technology. It's meant for anyone who wants quick and accurate insights into their skin health. For patients, SkinLens make it easy to upload images of their skin condition and receive an accurate diagnosis, along with recommended treatments and a brief description. For dermatologists, it provides a way to efficiently access patients' information and give professional input. Now, unlike traditional visual inspection, which can vary based on human interpretation, SkinLens uses a cutting-edge image-based deep learning model. This technology ensures accurate predictions and tailored treatment recommendations. On top of that, SkinLens includes a real-time consultation feature, allowing patients to connect with dermatologists for personalized care. The benefits are clear. SkinLens improves diagnosis accuracy, provides faster and more personalized care, increases accessibility to expert advice, as well as it reduces overall cost and gives patients real-time access to dermatologists. By combining technology with healthcare, SkinLens bridges the gap between patient and quality dermatological care. Next slide. This is a different format in which we wrote our project description so that it is clear for everyone to understand. Next slide.
Hello everyone, this is our team working agreement. We discussed and wrote down this agreement to define how we do teamwork within our best group. First part is communication expectation. We use Slack to do communications, and the most important is all team members' opinions and ideas will be respected, and changes, if any, should be discussed and make agreement within the team. And then about the meeting structure and the frequency. First, we use Zoom to do the remote meeting, and we have daily Scrum meeting, and maybe follow our meeting if we can't quickly address the problems, and spring plan meeting, spring retrospective meeting in the each sprint. And we encourage everyone to actively participate in the meeting. And as a Scrum Master, I will host the meeting and control the time. And about team norms and value, first, each team member understand their roles and the responsibilities, and we will divide the tasks transparently and help each other when necessary. And each task should have a clear due date and accepted definition of done. And at the rest side, we have details about the definition of done. And each team member takes responsibility for their tasks and for achieving the team's goals. And if they meet some obstacles, they should report this obstacle immediately if they can't complete their work on time and actively contribute to the solution. And we also have some continuous improvement. For example, we encourage teams to do research, learn, and come up with new ideas and share with the team. And we will reflect on the areas of improvement during each spring retrospective so that our process is better for the next sprint. And I mentioned before, we have a definition of done. It's here. For example, the code should be pushed on the GitHub, and work has been fully reviewed by another team member, and and the task and the code should be tested, and no critical defects. For example, this. And then this is the project schedule. We have 4 sprints. Sprint 1 is September 6 to September 26. It's preparing, and sprint 1 is September 26 to October 24. Our goal is deliver the homepage, and user can upload image, and they will get AI prediction after they upload the image. And in the sprint 2, October 24 to November 21st, we will deliver. We plan to implement following features like make the AI prediction more can predict more skin conditions and gain more accuracy result. And we will also display the disease descriptions and treatment recommendations. And the users can generate a report and download it. And we will implement users account management systems for the future features development. And in the sprint 3, the last sprint, November 21st to December 12th, we will deliver following features like patient record, dermatologist dashboard, and the chat features. That's it.
Yeah. So, for our app, we have like three personas, like patient persona, parent persona, and doctor persona. So, coming to patient persona, her name is Nashli Pagiroli. She is like 30 years old and she's a female IT employee, and she is a very busy in their personal life, and she's living in a city with that pollution and everything. She'll got every time skin rashes, acne, like that. So challenges she faced is like she has like skin issues, and she always get the like delays while scheduling the appointments with dermatologist, and she's like very difficult to describe diseases, what disease it is, and she doesn't have that much knowledge on that skin diseases. And she always wants like fast treatments, like um like that. So goals, she wants like a reliable easy platform to access our skin issues quickly and get initial like a feedback without need any appointments, and she doesn't want to wait for the appointments too. And hopes to receive personalized treatment recommendations on based on like a skin type, age, and the previous medical histories. Yeah. So, coming to the parent persona, her name is like Gloria Garson, and her age is like 40 years old, and she's a housewife and balancing to take care of her four children, and household duties, and she has to take care of her husband too, and she wants to take care and little bit time to focus on her health too. So challenges she faced is like she has four children. um among her kids, always they'll get like skin issues like rashes, eczema, acne, like that. And she really get confused like because each and every children has different ages and the skin types. And it is like she always concerned about the cost and the time, like always visits the doctor, and it will get like too much cost. By using our app, her cost will decrease and her time also saved. So goals she reached is like she always personalized advice for each children's skincare, and like skin type, allergies, or past treatments, and hopes she'll save her time by using images and she uploads in our app. And she has finally she'll get like a peace of mind to receive an accurate um result. and she'll always thinks like home care is sufficient by using our app. Yeah. So coming to Dr. Persona, he is Dr. Robert Smith, and his age is 35 years old, and he's a dermatologist, and he's very busy in their working life, and he has both hospital and private clinic, and he always treat a high volume of patients with various skin conditions. Like a challenges he faced is like he has to manage a large patient load daily, and he has to provide a personalized personal care to each and every patient, and he often receive like incomplete descriptions of diseases, and accurately and diagnosed with accurately without further testing or follow-ups, and he always struggles to track patient treatments um like over time, like eczema or psoriasis, and due to irregular follow-ups and inconsistent data from patients. And goals he reach is like he wants a reliable platform like us to track the patient information, including images and medical history and reports, and allowing for quick results, and hope he'll track patient progress over time, helping to adjust treatments, and maybe he aims to reduce the patient times, and he'll do the chat and everything, and he'll review the report and everything in our app. So that will be the goal in doing that.
Okay, move to MVP. During this spring, we focus on enhancing the user experience and adding critical features. And next slide, please. And let's take a closer look at the key features of SkinLens. Next slide. Okay, let's see website, our web-based interface. The platform is designed to be user-friendly and accessible for both patients and doctors, whether it's uploading images or reviewing diagnosis. The interface makes the process simple and I think more easy to follow. And let's move to patient image upload. Patients can securely upload images of their skin condition directly to the platform. To ensure a thorough analysis, multiple images can be uploaded per case, allowing the AI model to evaluate the condition comprehensively. Let's see AI-powered diagnosis. SkinLens uses a pre-trained image classification model to analyze uploading images. It delivers fast and accurate diagnosis results for over 20 skin conditions, making it a powerful tool for identifying and managing skin issues effectively. And our diagnosis display, the results are presented clearly and concisely to the patient. Each diagnosis includes the predict skin condition, a brief description, and actionable treatment recommendations. Patients also have the options to generate a detailed report for their cases. Okay, let's move to our reports. So patient can generate downloadable, the PDF can download for their cases. And these reports also secure and provide a complete record of the diagnosis, including the uploading images, predictions, and recommendations. And also, finally, we can chat. SkinLens offer a real-time messaging feature allowing patients to consult with doctors directly. And this ensures seamless communication and provides patients with the personalized care they need. And together, these features make a SkinLens a comprehensive solution for diagnosing and managing skin conditions while bridging the gap between patients and expert care. And let's move to next slide. And we use Figma to do the website design. And here the picture can show you that what we did through the Figma. And that's like you can start your journey with this select image and upload it. And next, please. And then after that, you can get your predicted diagnosis. And next. Am I gonna introduce what technologies we used? And for front-end and back-end and database, we use JavaScript, React, Flask, Python, and Firebase, most of them. And TensorFlow, Python, and Keras, Colab, Docker, and Google Cloud and support our AI model. And we use Jira for our plan and use GitHub to push our code. And Figma, as I mentioned before, we use it for design, and we use Slack to communicate with each other. And next, please. And following, my teammate gonna give you guys details and specific information.
Yes. So we use like a React, White, and Tailwind CSS. So like firstly, what is React? It is an open source JavaScript library to it is used to create like a interactive and reactive user interfaces, and we can split like UIs into reusable components, and which will make our work easier to maintain and build large web applications. And coming to White, um, it is a fast and good web application building tool. It stands out for its like a to work to do our application fast, and it will like instant compilation times during development. So and for Tailwind CSS, it is an open source CSS framework we used to styling our web application, to styling our app. These three will uh like useful a lot in our app. Yeah.
Let's dive into the technology and backend that powers our SkinLens app. Let's discuss about Flask backend server. At the core of SkinLens is a Flask backend server, which plays a critical role in integrating with our AI model. Now, Flask is exclusively used to host and manage a TensorFlow-based image classification model. It processes image data sent from the front end, runs it through the AI model, and returns accurate diagnosis for over 20 plus skin conditions. Now, acting as a middleware, Flask server facilitates seamless communication between our React frontend and the AI model. Next, moving on to the REST API for predictions. Flask provides a dedicated API endpoint for uploading images and receiving AI-generated diagnosis. This API handles data pre-processing before passing it to the model, which ensures smooth and efficient response delivery. Now, Flask has a lightweight nature which allows for quick deployment and efficient handling of requests, which keeps the architecture modular by separating AI-related operations from other functionalities. Next slide, please. Moving on to the real-time features. SkinLens also integrates real-time capabilities, uh, To enhance user experience, uh, patients receive real-time updates on their case status and dermatologist comments. The platform supports real-time chat for instant consultations, ensuring direct communication between patient and dermatologist. Now, notifications are also sent in real time to the users about new messages, keeping everyone informed. The reason is why Firebase. To simplify backend management, we leverage Firebase for authentication, storage, as well as database operations. Firebase provides robust security measures that meet healthcare data and privacy standards, ensuring the safety of sensitive information. Now, its real-time data update capabilities enhance the user experience, providing instant synchronization across devices. Now, additionally, Firebase is highly reliable, scalable, and requires very minimal maintenance, making it an ideal choice for a healthcare-focused application like our app that is SkinLens. Next slide. So let me explain the workflow. Maybe you can go to the next slide. Okay, so let me explain the workflow of course and Axios, how it is being integrated in our app, because the React is hosted on a different server and our Flask server is hosted on a different server. So to address this issue, we are implementing course. Now, let me explain the workflow in this diagram, which showcases how SkinLens handles secure and seamless upload of patient images using Axios, Flask, Course, and Firebase storage. Now, first, the process begins with patient using the React Web application to select and upload an image of their skin condition. This is the starting point where the user initiates the interaction. Next, the React web app acting as the front end, it uses Axios, which is a JavaScript HTTP client, to send an HTTP post request to the Flask backend. Now, this request contains the image file that needs to be processed. When the Flask API receives the request, it checks the course policy to ensure that the request is coming from an authorized domain, such as the one hosting the front end. Now, this is a key security step to prevent unauthorized cross-origin request. Next, if the course policy validates the request, the Flask API proceeds to securely store the uploaded image in Firebase storage, which is a reliable and secure platform as we discussed before. Now, once the image is successfully uploaded, the Flask API sends an HTTP response back to the Axios HTTP client, which confirms that the upload was successful. Next, the React web app receives the response and displays a success message to the patient, confirming that their image has been uploaded and processed. Now, the highlighted section at the bottom of the diagram explains the key components of the process. That is, the front end relies on Axios to handle HTTP requests, and the backend enforces a strict course policy to allow only authorized cross-domain access. Next slide, please. Let's look at the key features of Firebase in the SkinLens platform and how it supports our application. First, authentication. Firebase handles secure login and sign up for both the users, that is patient and dermatologist. Now, using role-based authentication, Firebase controls access to specific areas like dashboard, cases, and reports. Now, this ensures that patients and dermatologists only access information relevant to their roles. Moving on to Firestore database. The Firestore database is like the backbone of our data management. It stores like a variety of things, like it stores user profile, including details like name, email, role, and a unique ID. Firestore also maintains the record for each case, including metadata, AI generated predictions, description, and treatment recommendation. It also stores like case statuses such as open, reviewed, uh, which can be tracked in real time, ensuring accurate updates for both patient as well as dermatologist. Now, moving on to the Firebase for storage. Firebase storage securely manages the skin conditions images uploaded by the patients. Files are organized by unique case IDs, which makes them easy to access for further analysis or report generation. Let's talk about the security and scalability that Firebase provides. One of the one of the Firebase standard features is its built-in security rules, like which protect sensitive data for both patient and dermatologist. These security measures meet healthcare data protection standards, ensuring privacy and compliance. Can we next slide?
Yeah, hi. When it comes to the algorithms, we use TensorFlow and Keras for CNN model and data augmentation, and we have used OpenCV library for image pre-processing, Matplot library for visualization. Next slide, please. So system architecture. So first, database of skin images. For the SkinLens project, we began by utilizing a comprehensive database of skin images. These images are labeled to represent various skin conditions, forming the foundation of our AI-based diagnosis system. Next, it comes to the data pre-processing. The raw images from the database were pre-processed to ensure they were ready for model training. This involves resizing, normalizing, and removing noisy or incomplete data. This pre-processing step was crucial to ensure the reliability and accuracy of the system. Then next, data splitting. After pre-processing, data was split into three subsets for different stages of model development. First, training data, which is used to train the CNN model. Validation data, used to monitor and fine-tune the model. And test data, reserved for evaluating the final performance of the model. Next, data augmentation to address the challenges of data imbalance and limited sample diversity. We applied data augmentation techniques. This includes flipping, rotating, and cropping images, also adding variations to stimulate real-world conditions. So CNN model at the core of our SkinLens lies a CNN model. Instead of using single CNN model, we use combined multiple fine-tuned CNNs model. So at the last model output, this model generates predictions in the form of probabilities for each skin condition. Then these outputs include most likely diagnosis along with confidence scores, making it easier for both patients and dermatologists to interpret the results. So next slide, please. So CNN architecture. CNN architecture is designed to extract features from input images of skin conditions and classify them into one of categories of the classes using combination of convolutional pooling and dense layers along with the techniques like dropout and batch normalization. Let me just give the overview of the layers used. Convolutional layers. These layers extract features like edges, textures, and shapes from the images. Max pooling layers. These layers reduce the spatial dimensions of the feature maps, making the model more efficient and reducing overfitting. Batch normalization. It normalizes the output from the CNN layer to stabilize and accelerate training. Dropout layer randomly sets some neurons to zero during training to prevent overfitting. We have used dropout as 0.5, which reduces around 50% of the neurons in this layer to zero during each training steps to prevent overfitting. So the reason why we preferred Adam Optimizer is one, it combines the benefits of momentum and RMS prop adaptive learning rates. Adam dynamically adjusts learning rates, making it more robust in practice, especially when dealing with the complex models and datasets. Next slide. Abhi, you are on mute.
Yes, let's come to the model structure. So this image illustrates the step-by-step process of how convolution neural networks, that's called CNN, process a skin disease image for the classifications. So this will divide in the five layers. So the first layer is input layer, which process begin with the as an input image such as image of skin disease. This layer handles the raw pixel data and prepare it for the further process. Second layer is convolution layers, which extract features from the image such as age, texture, and the patterns. This image is passed through the filters known as kernels that scan small sections as a patch of the image to detect the features. So the feature map highlights important region of the input image. Then it's come to the pooling layer. So pooling layer reduce the spectacle size of the features map up to the focus of the most critical feature which minimize the computational load. So this technique like model pooling, selecting the most prominent feature is a region to prevent the key informations. Then it's come to the heading layer. So the heading layer flattens the feature map into a single vector and pass it through the full connected layer. That's called a dense layer. So this layer, the heading layer learn the combination and extraction of features to distinguish between the different class such as type of the skins. And the final layer is output layer that's produce the final classification results. So the each node in the output layer represent a single specific class, such as we have a 21 skin disease types, which probabilities indicates the model conference from the each class. So the input layer, convolution layer, and pooling layer detect the pattern and the comprehension information in the feature map and the feature map, heading layer, and the output layer convert the features into a disease label. So for our skin lens, this process allows CNN to learn directly from the data, makes them ideal for the image-based diagnosis like skin lens detections. So the benefits are automatic feature extraction. So we don't have to do a manual efforts required to do this and handle complex dataset which with a high accuracy. Next slide, please. So this is a screenshot of our model testing. Okay, so first I have uploaded an image of a skin disease for the prediction. So the AI model process the image through the CNN pipeline, extracting features, classifying it. That's class number. So we have seen that's class number 10. So it's mapped with the class disease called melanoma, a serious form of skin cancers. So this model took the 110 milliseconds to deliver the results. Source its speed and the accuracies. So this demonstrates the model potential to assist in the early detection of the life-threatening disease. Next slide, please.
So yeah, and let's see the diagrams we have designed for our SkinLens project. So architecture diagram. The patient uses the UI, which is built with React to upload images of the skin condition or communicate with a dermatologist through the chat service. The UI then sends the images and patient data to the backend Flask API. The Flask API processes this request and interacts with the AI model to predict the skin condition disease. The AI model processes the images and generates predictions. The Flask API then sends the results back to the front end for display to the patient. Also, all the images, case details, and chat conversations are stored in the database for future reference and record keeping. For the real-time communication, patient can also engage in real-time chats with the healthcare provider where the chat data is recorded in the database. Next slide, please.
Okay. Um, Let's move to the contact diagram. This shows how the SkinLens system works and how its key components interact to provide a seamless experience for diagnosing and managing skin conditions. Let me explain the main parts step by step. At the center is SkinLens, the main platform that connects all parts of the system: patients, doctors, the AI model, and the database. Everything flows through SkinLens to deliver its features. And on the left, patients upload images of their skin conditions. SkinLens process these images and provides a confirmation, diagnosis results, and treatment recommendations. These results are shown to the patient through the patient display interface. And at the top right, the AI model processes the uploaded images. SkinLens send the image to the AI model, which analyzes it and returns the diagnosis. This result is then shared with the patient. And on the bottom right, the database securely stores information like user profiles, uploaded images, diagnostic reports, and treatment history. This ensures data is accessible for both patients and doctors. On the bottom left, doctors can access patient cases through SkinLens. That they can review cases, add input, and provide expert feedback, helping create more detailed treatment plans. And at the top center, the patient displayed interface shows patients their upload confirmation, diagnosis results, and treatment recommendations in a simple and clear format. Okay. And next.
So, actually, like the sequence diagram I made was quite long, and it was hard to include it in one particular slide without messing up the clarity. So I divided it into three parts. So this is the first one, and let me walk through the sequence of events in this diagram. First, let's talk about image upload. The process begins when the patient uploads an image through the front end. At this point, system checks if the user is authenticated. For authenticated users, the image is securely stored in cloud storage, and a URL is generated for further processing. And as far as guest users are concerned, the image is stored temporarily, and a temporary URL is created with a timer set for automatic deletion to ensure privacy of the guest users. Next, diagnosis processing. Now, once the image URL is ready, it is sent to the Flask backend, which forwards it to the AI model. The AI model analyzes the image and provides a diagnosis prediction. This results, along with with any necessary metadata, is returned to the backend and then sent to the front end for display to the patient. Let's talk about case data management. Now, for authenticated users, the diagnosis and related metadata are saved securely in Firebase as a database, allowing them to access these records later on. Now, guest users, on the other hand, do not have their data saved. Instead, the temporary image is scheduled for deletion, as I told earlier. Now let's talk about displaying results. The diagnosis results are then displayed on the front end for the patient. This ensures that patient can quickly understand the condition and take any recommended next steps. Authenticated users can access the patient record section to view their previous cases. Now, the system fetches their case history from the database, and patient can search, filter, and sort their records based on different features for better management. Next slide, please. Yeah, so let me explain how the chat functionality in SkinLens operates. As you all can see in the diagram, it shows how patients and dermatologists communicate effectively through the platform. The process begins when a patient or dermatologist views the list of available users with the opposite role. That is, patient can view all the dermatologist and dermatologist can view all the patients. The front end fetches this data from the Firebase database, which includes users along with the count of unread messages for each of them. Then once a user selects someone to chat with, the system either creates a new chat session or fetches an existing one. The Firebase database retrieves and returns the chat messages for display on the front end. Now, patients and dermatologists can then exchange messages in real time. When a message is sent, it is saved in the Firebase database with a status of sent. The system updates the message status to delivered or read when the recipient, that is the other dermatologist or a patient, the other person on the end, accesses it, ensuring clarity in message delivery. Users can also have the option. They also have the option to upload images as part of the chat. The uploaded image is stored securely in the cloud storage, and its URL is returned to the database. The image URL is then saved in the chat session and displayed to the recipient. And as well as to make the interaction more fun, more friendly, we have also included uh, chat in the chat feature. We can also send emojis to communicate with each other. Next slide, please. Now, this diagram explains how dermatologists interact with the SkinLens dashboard to review and manage cases. The process starts with dermatologists logging in through the front end. Once logged in, the system verifies the user's role, that is, if they are dermatologist or not, using the Firebase database. Now, for valid dermatologist, if the user is authenticated and has the correct role, they are granted access to the dashboard. And if the role check fails, the user is redirected to the login page. Now, once logged in, the dermatologist can view all the cases. The front end fetches all case details from the Firebase database and displays them in a good format. Dermatologists can filter and sort or query specific ones based on the preferences such as status or patient details. The database returns the filter results to the front end for easy case management. Now, when a dermatologist selects a specific case by clicking on a take action button, the front end fetches the corresponding case data from the Firebase database. Uh, this database includes all the patient information, diagnosis, and treatment recommendations. And after reviewing the case, the dermatologist can add comments or update the case status. That is, if the dermatologist adds a comment, the status is already updated to reviewed. Now, these updates are submitted to the Firebase database, ensuring that the case data remains current and accurate. Now, uh, once the case review is complete, the status is changed to reviewed. Now, next slide, please.
Okay, this is the ERD. Full name is Entity Relationship Diagram. It includes the entities involved our application and also their attributes and also the relationship between these entities. First, we can see there are two different kinds of user, patient and dermatologist, and also their attributes like the primary key, there is ID and the UID and their name, email, for example, and the role. This role is how to divide them into a patient and the dermatologist. And we also have the most important entity case. It includes so many attributes and informations. And also the skin conditions. When application predict the disease, it will fetch the detailed information of skin conditions from this entity. And the images of the like patient upload images, and these images are individual entity storing the graph in individual storage is better for database management and scalabilities. So we have the patient image entity and also the chat image entity. And also we have a chat entity to implement the chat feature. It includes the information of the chat, like who participated the chat, person one, person two, and the messages and the meta data of the messages.
Yeah, coming to state diagram, so first, we have to, like, we have a user check, like, we have two things like authenticated user and the guest user. So, and we have to create an account, and then we can log in it. Like that also we have. And coming to for guest, then the user will like a login, then it will go through like it will store like temporarily, and after that user can use the um AI processing to store the image. Like a user can take any image to store it in the computer, and that will like that image can like a process in the AI model, and after that will get ready for the diagnosis. And after that patient has to go through the home page, and user can upload the image, then we'll get the result after that. And patient has like um uh, three things like upload image, chat, and view the reports, like that. So if patient can upload the image, then patient can get the accurate results. And if patient has any doubts or anything, patient can chat with the dermatologist. And coming to the chat system, after that, coming to the chat system, patient can initially chat with the dermatologist, or send a message, or receive a message. And after reviewing the chat, um, dermatologist also chat to the patient and give some suggestions about the skin diseases. Then the chat will end. After coming to the login, we have two logins, like dermatologist login and the patient login. If the authentication is successful, it will directly go through the home page, like whoever um login into our app. Like if for example, if you take the patient, if patient create an account and log in it, it will directly go through the patient homepage. If you take the dermatologist um login or something, so it will go through the directly dermatologist homepage. So if any error or anything, it will show you like invalid login, like that, then it will give the error. So coming to the dermatologist homepage, dermatologist can access our patient reports, and dermatologist can review our reports. And patient doctor dermatologist can give some comments about our skin diseases, like that. And if a dermatologist access their dashboard and view the cases and give the comments, and again back to the dashboard, like So like that we have so like that dermatologist will do in our app, like, and the patient also, like, first they'll patient can upload the image, and they'll get the accurate results. Then patient can see their reports, and patient can do the chat to the dermatologist. And we have we have some info about our skin diseases too. So yeah, like that.
Yeah, let's see the workflow of concept diagram. Patients uploads images of the skin condition, then the AI model processes the images and provides an initial diagnosis. The patient receives the AI diagnosis and can request further insights from a dermatologist. Then the dermatologist reviews the diagnosis, adds comments, and consults with the patient through the chat system. Both the AI diagnosis and the dermatologist review are compiled into a final report which is provided to the patient. Next slide, please.
Okay, so let's come to the class diagram. So uh, this is the class diagram. So the primary class is patient, interact with other components such as AI models, report, dermatologist, and chat. So the patient upload the image analyzed by the AI model. So it generate the predictions that store in the form of report class. So report can be directly accessed or reviewed by the dermatologist for additional insights. So and the chat class facilitate the communication between the patient and the dermatologist for the clarifications. So the relation between class such as patient generate report and the dermatologist review report ensure the seamless workflow. So this diagram demonstrates the logical connection and enhance the understanding of our system functionality. Next slide, please. So this is a this is our sprint two recap. So Uh, first we have the extended the number of skin conditions app can be recognized. So we have like increase the number of skin conditions up to 2021. Then we have done the create a fire-based storage to store the image. After that, we have created the file storage, data storage to store the cases. So when the reports are uploaded, that's stored in that Firebase. After that, added the brief description and the uh, treatment recommendation while patient get the diagnosis. So like once the image is uploaded and they get the brief diagnosis of the disease that the uh, detect by the AI models. So after that, we have done the development, the process feature so that the patient can review and download the image. So we have done one feature that patient can download the image, download the report. So if he need for the further treatment. And the last one is develop the sign up login page and create the file database to store the user account. Okay, so next slide, please.
Hello everyone. This is a Sprint 1 banner chart. In Sprint 1, we plan to develop the image upload page and complete the core feature, give users AI diagnosis after users uploading the images. But in Sprint 1, we spend too much time on defining user stories, so we have less time. I think maybe 2 weeks for development, I mean writing codes. Um, and we are the beginner in deep learning field. So at the end of sprint 1, we still have some obstacles can't be solved. So we didn't 100% implement the application as our planning. And in sprint 2, We had festivals and midterm exams, so we at a standstill at the beginning. You can see from October 27 to November 5, we are at a standstill. But then we found we need to make efforts, so we tried our best to work overnight and catch the progress. Finally, we successfully delivered the condition description feature, treatment recommendation feature, and report feature.
So let me walk you all through the product backlog. It's quite long, and there are around 32 user stories and 7 technical stories, which we worked on in all sprint 1, sprint 2, and sprint 3 together. Uh, let's discuss the first user story. As a patient, I want to access a home page and start a new case so that I can begin my skin condition assessment. And the corresponding acceptance criteria is given the patient opens the application. When they navigate to the home page, then the home page is displayed with options to start a new case and clear instructions on how to use the app. And given the patient is on the home page, when they click the start new case button, then they are directed to the new case interface. And the feature this user story comes under is image upload, and the story points assigned where to. Let's go on to the user story number 2. As a patient, I want to access an interface to upload images so that I can provide information about my skin condition. Given the the corresponding acceptance criteria is given the patient starts a new case. When they proceed the image upload step, then an interface appears where they can upload images. uh, and given the patient is on the image upload interface, when they choose to upload an image, then they can either select an image from the device or drag and drop it onto the upload section. This also comes under the image upload feature, and as it is quite a lot of work to do, it was assigned 5 story points. Let's move on to the user story number 3. As a patient, I want to select an image from my device and upload it so that it can be used for diagnosis. The corresponding acceptance criteria is the patient can select an image file from the device. The system accepts specified formats: JPEG, JPG, and PNG. This also comes under image upload feature, and story point assigned of 5. User story number 4. As a patient, I want to receive a confirmation message and see a preview of my uploaded image so that I know it was uploaded successfully. And the corresponding acceptance criteria is given the patient uploads an image successfully, when the system completes the upload process, then a confirmation message is displayed on the screen. And given the image is uploaded successfully, when the system processes the image, then a thumbnail preview of the uploaded image is displayed on the interface so that the user know that they uploaded the correct image. This also comes under image upload feature. Next slide. User story number 5. As a patient, I want the app to analyze my image and recognize basic type of skin conditions so that I can receive a preliminary diagnosis. The acceptance criteria is given the patient has successfully uploaded an image. When they click the analyze button, then the app uses the trained AI model to classify the skin condition. Uh, Initial classification accuracy. Given the model is trained to recognize 5 common skin conditions, when an image is analyzed, then the prediction results are displayed based on the model's classification. This comes under AI diagnosis feature, and 8 story points were assigned to this feature. Uh, let's move on to the user story number 6. As a patient, I want to receive the diagnosis as the name of the condition so that I can understand the skin issue. Acceptance criteria is given the model completes the analysis, when a diagnosis is generated, then the name of skin condition is displayed clearly on the patient screen. And given the diagnosis is presented to the patient, when it is displayed, then the name of condition is shown in an easy to read and user friendly format. And this also comes under AI diagnosis feature. And on the top right, of the slide, you can see a legend of sprint 1, sprint 2, and sprint 3. Similarly, the table row colors are like the green is for sprint 1, light blue is for sprint 2, and white is for sprint 3. Let's move on to the user story number 7. As a patient, I want the uploaded image to be securely stored so that I can access my report anytime. Acceptance criteria is given the patient uploads an image, when the upload process is successful, then the image is securely stored in Firebase storage with a unique case ID. And image accessibility, given the patient has logged into their account, when they access their case details, then all stored images are displayed and linked to the relevant case. This user story comes under image handling feature. Now, next user story. As a guest user, I want my uploaded image to be deleted after processing so that it does not remain stored unnecessarily. Acceptance criteria is given the guest uploads an image, when 5 minutes have passed after upload, then the image is automatically deleted from the Firebase storage. This feature also comes under image handling. Next slide. User story number 9. As a guest user, I want the system to alert me if my temporary image is unavailable after the session so that I can re-upload it. The corresponding acceptance criteria is given the guest temporary image is deleted due to timeout, when they attempt to proceed, then the system displays an alert notifying them about the inability and re-upload option. Given the guest image is deleted, when they choose to upload a new image, then the system provides an option to re-upload. This user story also comes under image handling feature. The next user story, number 10. As a patient, I want clear error messages if something goes wrong during upload or prediction so that I can take corrective actions. Given the acceptance criteria is given the patient uploads an invalid file or encounters a failed upload, when the system detects an issue, then an error message is displayed explaining the problem as well as steps to resolve it. And retry options, given an error occurs during upload or prediction, when the patient chooses to retry, then the system provides a retry button to reattempt the process. This also comes under image handling feature. Moving on to the next user story, number 11. As a patient, I want the app to recognize a wide range of skin conditions so that I can receive a diagnosis for diverse issues. The corresponding acceptance criteria, given the patient submits an image, when the diagnosis is completed, then the app provides predictions for 20 plus skin conditions with clear names. This also comes under AI diagnosis feature. Moving on to user story number 12. As a patient, I want the diagnosis accuracy to be improved so that I can trust the AI's result. And the corresponding acceptance criteria is given the AI model is retrained with additional data, when new predictions are made, then the accuracy threshold meets or exceeds 80% for common conditions. This also comes under AI diagnosis feature. Next slide. Moving on to the user story number 13. As a patient, I want to receive the diagnosis result as soon as possible so that I can act quickly if needed. Acceptance criteria is given the patient uploads an image for diagnosis, when the system processes the request, then the results are displayed within a minute. And for delay notification, given processing exceeds the expected time, when the patient waits, then the system informs them of the delay and provides an estimated wait time. This also comes under AI diagnosis feature. Moving on to the next user story. As a patient, I want to receive a brief description of the diagnosed condition so that I can understand about the skin issue I am facing. Corresponding acceptance criteria is given the diagnosis is completed, when the result is displayed, then a brief description is provided in clear, understandable language, including common system and causes. This also comes under AI diagnosis feature. User story number 15. As a patient, I want to receive treatment recommendations so that I can take action towards treating my skin condition. And the corresponding acceptance criteria, given the patient receives a diagnosis, when the system displays the result, then evidence-based treatment recommendations are provided, including over-the-counter remedies or advice to seek professional care. This also comes under AI diagnosis feature. Moving on to the next user story. As a patient, I want to view a comprehensive report of a case so that I have a complete record of my skin condition assessment and the corresponding acceptance criteria. Given the patient accesses their case, when they open the report, then it includes metadata, patient details, uploaded image, diagnosis, description, and treatment recommendations. This user story comes under report feature. Next slide. Uh, yeah, user story number 17. As a patient, I want to download a detailed report as a PDF so that I can share it with a dermatologist or keep it for personal records. The corresponding acceptance criteria is given the patient opens the report, when they click the download PDF button, then a PDF version of the report is generated and downloaded, matching the layout of the web application. This also comes under report feature. User story number 18. As a patient, I want the ability to print my report directly from the app so that I can have a hard copy when needed. And the acceptance criteria is given the patient opens the report, when they click the print button, then a printable version of the report is generated with a clear and professional layout. This also comes under report feature. User story number 19. As a patient, I want my reports to be secure and accessible only by me so that my medical data remains private. The acceptance criteria corresponding to secure access is given the patient logs into their account, when they access their reports, then the system verifies their identity first and ensures only then they can view the data. And acceptance criteria for data security is given the patient's reports are stored, when the system handles data, then secure storage methods like Firebase and Firestore encryption are used to ensure privacy. This comes under report security and privacy feature. Moving on to user story number 20. As a patient, I want to view my past cases and track their statuses so that I can monitor my health progress and stay informed about the evaluations. The corresponding acceptance criteria for case history access is given the patient logs into their account, when they navigate to the case history section, then they can view a chronological list of all past cases. The acceptance criteria for real-time status updates is given the patient views their case list, then the status of a case changes. Then the system updates the status in real time without requiring a refresh. Uh, and the acceptance criteria for navigation to report is given the patient clicks on a case entry, when the system processes the request, then the patient is navigated to that case's report. This comes under this comes under user account management feature. Next slide, please. User story number 21. As a dermatologist, I want to access and view patient reports so that I can assess their conditions and provide professional feedback. And the corresponding acceptance criteria for access reports dashboard is given the dermatologist logs into their account, when they navigate to the dashboard, then a list of all assigned patient reports is displayed. And the acceptance criteria for report sorting options is given the dermatologist is on the report's dashboard, when they apply sorting filters, for example, by date, status, or patient ID, then the system dynamically updates the displayed list. This comes under user account management feature. Moving on to user story number 22. As a dermatologist, I want to add comments to patient reports so that I can provide additional guidance if necessary. And the acceptance criteria for add comments is given the dermatologist opens a patient report, when they enter comments in the designated text field, then the comments are saved and associated with the report. And the acceptance criteria for visibility of comments is given the dermatologist submits comments, when the patient views the report, then the comments are displayed in the relevant section. This user story comes under dermatologist review feature. Moving on to user story number 23. As a patient, I want to be notified as soon as my report is reviewed by a dermatologist so that I can stay informed about my case status. Uh, the acceptance criteria for notification delivery is given the dermatologist submits their diagnosis and comments, when the report status changes to reviewed, then the patient receives a notification. Acceptance criteria for notification content is given a notification is sent when the patient opens it, then it includes a brief message indicating that the report has been reviewed and instructions on how to view the updated report. This also comes under dermatologist review feature. Moving on to user story number 24. As a patient, I want to access a chat interface from my report page so that I can communicate directly with the dermatologist. And the acceptance criteria corresponding to this user story is given the patient is on their report page, when they click the chat button, then a chat window opens displaying active chat requests. This comes under chat feature. Next slide. User story number 25. As a patient, I want to message my dermatologist in real time so that I can get quick answers to my question. And acceptance criteria for real-time messaging is given a patient initiates a chat with a dermatologist, when they send a message, then the dermatologist receives the message in real time. And the acceptance criteria for chat features is given a chat session is active when messages are exchanged, then each message includes a time stamp and typing indicators. This also comes under chat feature. Moving on to user story number 26. As a patient, I want to send images to dermatologist so that I can provide additional visual information about my skin condition. And the acceptance criteria for send images is given the patient is in a chat session, when they select and send an image, then the image is uploaded and displayed in the chat interface. And acceptance criteria for supported format is given the patient sends an image, when the system processes the image, then only supported formats are accepted. This also comes under chat feature. User story number 27. As a patient, I want to review the chat history with my dermatologist so that I can refer back to previous discussions and recommendations. And the acceptance criteria for access chat history is given the patient is in an active chat session, when they open the chat interface, then all past messages are displayed in a chronological order with timestamps. This also comes under chat feature. User story number 28. As a dermatologist, I want to chat with patients in real time so that I can provide the personalized consultation and answer their questions. The acceptance criteria for access active chat request is given the dermatologist logs into their account, when they navigate to the chat list dashboard, then all active chat requests from patient are displayed. Uh, and the acceptance criteria for real-time chat is given the dermatologist accepts a chat request, when messages are exchanged, then all messages include timestamps and attachments are supported. This also comes under chat feature. Next slide, please. So this is the last slide. Uh, Moving on to the user story number 29. As a patient, I want to sign up an account so that I can store my basic information and access personalized services. The corresponding acceptance criteria is given the patient accesses the registration page, when they enter their full name, email, password, and date of birth, then the system creates an account upon form submission. This comes under user account management feature. The next user story number 30. As a dermatologist, I want to sign up so that I can access patient reports and provide professional feedback. And similarly, user story 31 and 32 are login and for patient as well as dermatologist. And all of these four user stories comes under user account management feature. Next slide. So we have like 7 technical stories in the product backlog. The technical story number 1 is, as a developer, I want to finalize project diagrams so that I have a comprehensive visual representation of the system and its component. And the acceptance criteria is all the diagrams that are like architecture, context, and so on are successfully created. And technical story number 2, as a developer, I want to create test cases for Sprint 1 user stories so that I can verify the initial functionality is implemented correctly. And technical story number 3, as a developer, I want to write a technical paper on the project so that I can document its technical aspects and design decisions for future reference. And the acceptance criteria would be a technical report. A technical paper is reviewed by all the team members and it's done in a proper format. Technical user story number 4, as a developer, I want to create test cases for Sprint 2, similarly as Sprint 1. Next slide. And technical story number 5, as a developer, I want to create an installation manual. And technical story number 6 is, as a developer, I want to create comprehensive API documentation and test technical story number 7 will be, as a developer, I want to create test cases for sprint 3, similarly like we did in sprint 1 and sprint 2. That's it in the product backlog. Next slide.
So yeah, let's move on to the sprint 3. The sprint 3, we have like we'll carry from sprint 2, we'll carry 4 user stories and with 9 story points from sprint 2, and we can and user stories for sprint 3, we have 9 user stories and 23 story points, and we have 5 technical user stories. So so for sprint 3, we did like a chat feature. We create chat feature, and we create a dermatologist dashboard to access like patients reports, and reviewed the reports and give the some comments. So yeah, and we did everything
क्या बोल रही क्या रो?
from sprint 2. Yes. So that is for sprint 3 backlogs. Uh, Go to the technical user stories. We have 3 technical user stories, um, and uh, 5 story points. So yeah, that's it.
So yeah, hi. We have designed the test cases to verify the features worked as expected, providing a patient with smooth experience when uploading images and receiving a diagnosis. So for the user story 12, we have created 2 test cases. 1201 validate AI model accuracy. To proceed with this test case, steps description as follows: input a diverse dataset with known conditions, then test the model on unseen cases. As expected, the AI model achieves a predefined accuracy. It was about 94% on a validation dataset, and it has passed. Also, test case 1202 validate rare case predictions. While coming to the step descriptions, input cases with rare conditions, then check the model predictions. Then the AI model identifies rare conditions accurately within the dataset. It also passed. Next slide, please. For the user story 17, we have created 2 test cases: generate PDF report and verify PDF download functionality. But the system doesn't generate the PDF report with all relevant details such as patient info, diagnosis, and recommendations. As expected, it got failed. Uh, yeah, next slide, please. So for the user story 20, we have created 3 test cases: 2001, 2002, 2003, view past cases list, view case status, filter cases by status. As expected, results are: a list of past cases with the statuses is displayed. The case displays statuses such as pending, reviewed, or in progress. Only cases with the selected status are shown, and the execution status for all 3 test cases are pass. Next slide, please. So for the user story 21, we have created 2 test cases, 2101 and 2102, as follows: access patient reports and view patient report details. So for expected results for the test case 2101 is: a list of patient reports is displayed. It has passed the execution status. And for the test case 2102, report displays patient details, uploaded images, and symptoms. It has also passed. Next slide, please. So for the user story 22, we have created two test cases 2201, 2202 as follows. Add comments to the reports, validate comment input. The dermatologist comments are saved and visible in the report, and also an error message prompts for valid input. So these two cases have been passed and the execution status as seen as pass. Next slide, please. So for the user story 23, we have created two test cases 2301 and 2302 as follows. Receive report reviewed notification and notification links to report. As we were unable to do this feature, so the execution status got as failed. And for the user story 24, we have created only one test case 2401. Access chat interface from a report page. So chat interface, as expected, the chat interface is displayed, and this test case has been passed. Next slide, please. So for the user story 25, we have created two test cases 2501 and 2502 as follows. Send images in real time for the patient. As expected, message is delivered instantly and it got passed. For the test case 2502, received messages in real time. Patient sees the reply instantly, and this test case has been passed. And we can see the execution status as pass. Next slide, please. For the user story 26, we have created two test cases 2601 and 2602 as follows. Upload and send images and validate supported file formats. So as expected, image is sent and visible to the dermatologist, and we can see the execution status as pass. And also for the 2602, as expected, an error message prompts to upload a valid image file. When we try to upload in different format, and we can see the execution status as pass. Next slide, please. So for the user story 27, we have created two test cases 2701 and 2702 as follows. Review chat history and access chat history from the report page. So as expected, uh, past messages and images are displayed chronologically, and we can see the execution status as pass, and also chat history for the corresponding report is displayed, and this test case has been passed. Next slide, please. For the user story 28, we have created two test cases 2801 and 2802 as follows. Send images in real time for the dermatologist. As expected, patient receives the message instantly and also received messages in real time. As expected, dermatologist sees the message instantly, and we can see the uh, as expected, we can see the execution status as pass. Next slide, please. For the user story 31, we have created three test cases 3101, 3102, 3103 as follows. Verify sign up form accessibility, validate mandatory fields, and verify account creation. As expected, the three test cases have been passed, and we can see the execution status as pass. Next slide. So for the user story 33, we have created three test cases 3301, 3302, 3303 as follows. Verify login form accessibility, validate login in correct details, verify role-based access control, and also expected these all three test cases has been passed, and we can see the execution status as pass. Next slide.
Hello everyone. This is the um user stories we completed and not completed in the spring 3. You can see we committed to complete several user stories in spring 3, but we have 2 user stories not completed. It's user story 17 about download report and 23 get notification.
Okay, let's come to our team philosophy. In spring 3, our team achieved a philosophy of 34 story points, which is higher than our historical average of 31 story points. This shows that we are not only maintaining consistency, but also improve our efficiency. To put this into perspective, our philosophy in spring 1 was 27 story points, followed by 33 story points in spring 2. Next, please. Next, okay, let's come to our burden chart. The blue line represents the ideal trajectory, and the orange line shows the actual progress made by our team. And if our plan went well, we should get a reducing workload day by day. But however, as you can see that it's a totally different story. And because I think because the weather is changed suddenly, so we kept getting the bad news, like somebody got ill and somebody got bad body condition, so we cannot just complete or finish our plan goal each day. And but good news, I heard that like Leslie's brother held a wedding, but however there is a sad story. He didn't and she didn't invite us, so we don't have the opportunity to join the wedding and crazy party. I mean, actually, I tell this story just want to say that plans often cannot keep up with reality, but thanks to we actually, I think we are lucky enough to have each other to be our teammate, colleague, even friends. Because during this time, even the whole the whole project, whole sprints, no one can play. Even somebody cannot just finish their part in time or need help. That always give us support, and everybody support each other, and we communicate a lot and help each other a lot. So even there is some sad story, there is some there was some difficult, we overcome it and we finish all of our goals. We fulfilled our goals in the end. Okay, let's go next. Next one is our committee ratio. And this one for spring 3, our committee ratio is 92%, which is a significant improvement over the previous springs. In this spring, we committed to 37 story points at the start and successfully completed 34 story points. Spring 1 had a committee ratio of 82%, and Spring 2 dropped slightly to 79%. However, in Spring 3, we achieved a higher ratio. And this makes me record one thing, like it begins with a wedding and end with a wedding, because I still remember at first, spring one, I asked for leave because I have to attend my best friend's wedding. But as I mentioned before, like Leslie's brother had a wedding and just 3 days ago. So that's why I say that it begins with a wedding and ends with an adding. And so in spring one and spring two, we got a little bit higher committee ratio than spring two, maybe because of the wedding. I mean, I just kidding. I think the main reason we have done this successfully because we have passion. Passion can conquer all difficulties. And yep, and we had no matter what we met. Actually, in spring two, we met a bottleneck over there, and we really had a hard time. But thanks to, as I said, we have the best teammate in the world. So we overcome all the difficulties, and we resolve all the questions and issues. And let me see, what should I say and what I want to say? I forgot, but I still remember that. Like, I really think we are lucky enough. And yeah, that's what I want to say. Next.
Okay, so let's come to our spring 3 retrospective. So over there, we discuss what went right, what if we were do it again, then what we would do differently, and the actionable items. So first, so each of us spent 10 minutes to write down what well went during the sprint. So we focus our achievements and the positive aspect of our teamwork and the project evacuation. Then we took another 10 minutes to consider what we can do differently. So we thought about challenges we face and how we might tackle them differently in future sprints. So based on the what we would differently, we discuss the actionable items. So let's come to the retrospective. So first we discuss the same slides, please. Okay, so first we discuss what do we do right. So the brainstorming ideas. So one of our strongest points this sprint was our brainstorming session. So each step of the project benefit for us to collaborate thinking, leadership to innovative solution and the creative ideas. And second point is well-defined user stories and tags. So our clarity is defined user stories and tags were another major success. The clear definition helped every team members to understand exact what expected, ensuring everyone knew their responsibility and their deliveries. And let's come to point number 3. So user-friendly interface. So we successfully implement a user-friendly interface that caters to all our user guests, patients, and our dermatologists. So this testament our forced user-centric design and development. And the fourth point is team efforts and dedications. So I want to acknowledge everyone that hardworking. Many of us work till midnights or even before the dawn to meet our milestones. These dedications are crucial in keep our project on track. And the fourth point is adaptive to change. So our ability to accept and adaptive to advice and change has been remarkable. It shows that flexible and commitment to the improvements to the projects. And last one is leadership and the management. So finally, the excellent managed by our team leaders and Scrum Master cannot be noticeable. So the leadership was pivot in achievement of our MVP successfully. So so next come to the next slide, please. Yeah, let's come to the if we were to do it again, then what we do differently. So we should prioritize the critical tasks. So firstly, prioritize the prioritize the tasks such as deciding on the final data set at the beginning would streamlines our workflow and reduce the spend on adjustment later. So this need to be a key focus right for our planning metrics. So and second point is if we should proactive in the tax management. So we should all take full responsibility of our parts. This include comings up alternating solution proactively if we hit a rollback, such as strategic will ensure continuous progress without delay. And coming to the third point, we should enhance collaboration through demos. So watching demos together as a team and discuss them immediately after will allow us to integrate the feedback and dramatically. It helps in the making the immediate movement and ensure everyone is aligned with our project directions. Then the 4 points is we should collaborate problem solving. While facing obstacles, it's crucial for us to collaborate, seek solution regardless of what task it is. So this team-oriented approach to problem solving will enhance our efficiency and forest a more supportive work environment. And the last point is we should deeper technical engagement. Lastly, a more in-depth initial research phase would benefit us. So downloading and testing previous models as well as learning deeper algorithms principle at the start will build a stronger foundation and reduce the iterative revision. Next slide, please. So let's come to the actionable items. So we have decided the tasks prioritize to the Z. So Z will take the lead in prioritizing tasks during our planning meeting. For example, focus on deciding the final data set earlier on. So this will help to streamline our entire workflow right from the start. Second point is responsibility and alternatives to everyone. So every member in expected to take the full responsibility for the tax. So moreover, it's a crucial that we all prepare with our latest and alternating solution for each tax to ensure we don't hit us problem and the backwards of the project. Okay, and the third point is demo review and feedbacks. So it's assigned to like for everyone after each new feature development, we will gather as a team to watch a demo together. This will be our routine to ensure immediate and constructive feedbacks, facilitate the quicker and integration and improvement. And the fourth point is collective problem solving by everyone. So everyone has whenever an obstacle is encountered, regardless of whose task it is, everyone is encouraged to contribute to finding the solution. This collaboration approach should be part of a daily work ethics, ensuring that no one struggle alone and that issue are addressing swiftly. And the last point is deeply research and familiar with the technology. So it means to for everyone, all the team members are tasked with the deepening their understanding of technological stack and the principle behind the model we use. This involve downloading, testing the previous model, and exploring the advanced algorithms at the beginning of the projects. Next slide, please. So this is our screenshot that we perform on idle boards of our the Sprint 3 retrospective. Next slide, please.
Uh, these are the few screenshots from the project demo. Leslie, you can go on one by one slide. You can move on to the next. This is the dermatologist dashboard. Next. This is how the report is viewed. Next. This is the patient record dashboard where patient can review where patient can view all the past cases. Next. This is the screenshot of chat feature. Next. Yeah, so now we have covered a lot so far. The tools and technologies we are using, the diagrams, the product backlog, and even how sprint went. But let's take a moment to look behind the scenes. Behind all the polished features and smooth functionality lies the backbone of the system, that is the APIs. They are like the unsung heroes that makes everything come together, turning hard work into something truly beautiful. All right, let's talk about the APIs, which are basically the tools that make all the features in SkinLens work smoothly. They help different parts of the platform, like the front end, back end, and the database, talk to each other. Each API has a job like logging users in, uploading images, managing chats, or fetching case details. These APIs are what keep everything connected and running efficiently, making our platform easy and reliable for both patients and dermatologists. Let me walk you through them one by one. So the first is the authentication APIs, the sign up API, uh, which is a key part of the SkinLens authentication APIs. This API creates a new user account with details like email, password, name, and role. It ensures users are securely registered and roles are assigned correctly. Using a post request via the Firebase SDK, this API first creates an account in Firebase authentication with the user's email and password. Then additional details like name, role, a unique ID are stored in Firebase. Next slide. Then the login API is designed to authenticate users and grant them access to the SkinLens platform. It works using a post request through the Firebase SDK. The user provides their email and password, which are verified by Firebase authentication. And upon successful verification, the API creates an authenticated user session and generates a Firebase token for secure communication. This implementation is simple using the sign in with email and password function from the Firebase SDK. This ensures that users can log in securely and access features based on their assigned roles. And on every slide of the project APIs, on the bottom you can see the key code that was used to implement this particular API. Next slide. The image handling APIs. The image upload API is a key part of SkinLens image handling APIs designed to upload user selected image to Firebase storage securely and generate a unique URL for accessing them. This API works indirectly through the Firebase storage. When a user selects an image file, it is uploaded to a uniquely defined path in Firebase storage, which includes the user's ID and a randomly generated identifier. And after the upload is completed, a download URL is generated for the image. The implementation involves creating a storage reference using ref method and uploading the file with upload bytes method, followed by the retrieving the URL with get download URL method. This API ensures secure and efficient image management for further processing. Next slide. The prediction API, which is like the most important among all the APIs. It is a vital part, enabling AI-based diagnosis of skin condition. This API works via a post request using Axios, which we discussed at the beginning of the presentation. It takes the URL of the uploaded image as input and sends it to the backend for processing. Then the backend uses the AI model to analyze the image and returns a response containing the predicted disease name, a brief description, as well as treatment recommendation. This implementation involves a simple Axios call, as you guys can see in the code. This API ensures a seamless flow of data between the front end and Flask backend, providing users with accurate and actionable diagnosis results. Next slide. Yeah, the temporary image deletion API is designed to enhance security and privacy by deleting temporary images uploaded by unauthenticated users from Firebase storage, that is the guest users. This API operates indirectly through the Firebase SDK, like it takes the URL of the temporary image as input and creates a reference image in the storage using ref. method and deletes the file with delete object method. What this API ensures is that temporary images are removed promptly, maintaining integrity and privacy of the platform. Next slide. Now, moving on to the case management APIs, the generate case ID API is used to create a unique identifier for each new case in SkinLens. This is achieved programmatically by combining UUID logic with sequential numbering. The API does not require any input and generates a case ID in the format like skin and incremental number. For example, we already have skin 1, then it generates skin 2, skin 3, so on. It retrieves all existing case. First, what it does is it retrieves all existing case IDs from the Firebase collection, and from this ID, it extracts the numerical part and finds the highest number from this and increments it to generate the new ID. Basically this API ensures each case ID is assigned a unique ID for effective tracking and management. Next slide, please. Now, the save case details API is responsible for storing detailed information about each case in Firestore. This particular API works via a post request using the Firebase SDK. It takes inputs such as patient ID, case ID, email, image URL, and timestamp. The API then creates a document in the Firestore cases collection, saving these details along with an initial status of open. This ensures that all case data is securely stored and it is easily retrievable for further processing or review. Next slide, please. The fetch case details API is used to retrieve detailed information about specific cases from Firestore. This API works via a GET request using the Firestore SDK. It takes case ID as input and then fetches the corresponding document from the cases collection and returns the case details, which includes patient information, image URL, and case status. This particular API ensures quick and reliable access to all relevant case details for reviewing or processing. Next slide. The update case status API. This particular API allows for the modifying the status of a specific case in Firestore, such as changing it from pending review to reviewed. This API works via a patch request using the Firestore SDK. It takes case ID and the new status as input and updates the corresponding document in the cases collection. Overall, this API ensures that case statuses are kept up to date, which facilitate better case tracking and management for both users, that is patient and dermatologist. Next slide. The next API in the case management API is the Dermatologist comment API, which enables dermatologists to add their professional comments or diagnoses to a case in Firestore. This API also works via a patch request using the Firestore SDK. It takes case ID and dermatologist comment or whatever input they give and updates the corresponding document in the cases collection. This API ensures that dermatologist feedback is recorded accurately, providing valuable insights for patients and maintaining case record. Next slide. And the last API in the case management is the fetch reviewed by API. It is used to retrieve the name of the dermatologist who reviewed a specific case from Firestore, so that so that it is mentioned in the report and patient can know which dermatologist reviewed their report, so that they if they need any further consultations, they can chat with that particular dermatologist. And now this API works via a GET request using the Firestore SDK. It takes case ID as input and then fetches the document from cases collection and retrieves the reviewed by field containing which contains the dermatologist name. This particular API provides clear information about the reviewer. Next slide. Let's move on to the chat APIs. The Fetch User List API is designed to retrieve a list of users available for chatting, filtered by their roles, as in patients gets dermatologist and dermatologist gets patient. This API works via a GET request using Firestore SDK. It takes current user's role as input and then queries the user's collection to fetch users with opposite roles. Uh, and this API particularly outputs a list of users, enabling seamless role-based chat initiation. Next slide, please. The fetch chat messages API retrieves chat messages exchanged between two users. This API works via a GET request using the Firestore SDK. It takes chat ID, which is typically generated by combining the two user IDs as input, and then this API fetches the corresponding document from the chats collection and returns the list of message in a chronological order. Next slide. Uh, the send message API facilitates sending a message, whether text or an image, to another user. This API works via a post request using the Firestore SDK. It takes inputs such as sender ID, receiver ID, message text or image URL, and timestamp. The message data is appended to the corresponding chat documents in the chats collection using array union. Next slide. The the upload chat image API allows users to upload images for chats and generates a downloadable URL for sharing. This API operates indirectly through Firebase Storage SDK. The process starts with the image file selected by the user from their device, which is uploaded to a designated path in Fire Storage using the chat ID for organization. And after the upload, a downloadable URL is generated for the image. Next slide. Next slide. Yes. And the update message status API is used to change the status of a message, such as updating it from send to deliver or read, similarly like WhatsApp. Now, this API works via a patch request using the Firestore SDK. It takes chat ID and the list of messages as input. The messages are iterated to identify those that meet the condition, like, for example, received by the current user and still marked as sent. Then the status of these messages is updated accordingly, and the updated list is saved back to the chat document in the Firebase. Next slide. The last API in the chat APIs is the fetch unread message count API. Basically, this retrieves the number of unread messages for each chat. This API works via a GET request using the Firestore SDK. It takes current user ID as input and filters through the messages in the relevant chats to count those where the receiver ID matches the current user and the status is not read. Next slide, please. Moving on to the report APIs, the first is the view report API, which allows users to fetch and view detailed case reports. And this API also works via a GET request, and it takes case ID as input and retrieves corresponding document from cases collection. And the output includes all relevant case details. Next slide. The next API is Generate PDF Report API, which enables users to download a detailed PDF version of a case report. This API works like client side, leveraging it uses libraries like HTML to Canvas and JS PDF. What it basically does is it takes an HTML element containing the report details as input. Then the element is rendered into Canvas using HTML to Canvas, and then it is converted into a PDF with JS PDF. Next slide. The fetch diseases details API retrieves specific information about a disease, including its description and treatment details. This API works via a GET request, and it takes the disease name as an input and queries the diseases collection in Firestore and fetches the matching document, and the output includes disease description and recommended treatments. Next slide. Moving to the dashboard APIs, the first API is fetch cases for Dermatologist API, which retrieves list of all the cases visible to logged in Dermatologist. This API also works via a GET request, and it does not require any input, and it fetches all the documents from the cases collection. Next slide. The next is the filter and sort cases API, which allows dermatologists to organize cases based on selected criteria like status. Now, this is implemented client side, enabling real-time filtering and sorting of data. This API takes a filter attribute, a search item, or a sort key as an input. and it filters cases by matching the attribute with the search item and sorts the result. Next slide. Next, we have a pagination API, which organizes cases into manageable pages, and it is also implemented using client-side pagination logic. Next slide. Now, the patient dashboard APIs. The first is the fetch cases for patient APIs. This API also works via a GET request using the Firestore SDK. It takes patient ID as input and filters the cases in case collection to match logged in user's ID and returns a list of their cases. Next slide. The filter and search case API is implemented similar to the Dermatologist dashboard API. Next slide. The last API in our SkinLens project is the fetch logged in user data API, which retrieves the details of the currently logged in user, including their name, email, and role. This API works via GET request using the Firestore SDK. It takes user ID as input and it queries the user's collection and return user details. Next slide. Now, this is a snapshot of the Flask API core and cores, as well as Axios on the right uh, from our code that we discussed in the earlier slides. Next slide.
So yeah, while coming to the future enhancement, we have three: integration of multimodal learning, combining image data with text-based inputs such as patient-reported symptoms and clinical notes to improve diagnostic accuracy and provide a more comprehensive analysis. The second one, AI-powered chat functionality. It enhance the chat feature with conversational AI to automate routine queries, provide preliminary suggestions, and improve response times for patients. And the third, appointment scheduling system. It adds an integrated appointment scheduling feature, allowing patients to book virtual or in-person consultations with dermatologists with reminders and notifications to ensure timely follow-ups. Next slide.
So to see our final work, you can click on the link below, which is a GitHub link where a wiki page is visible with all the details and all the work we did as part of this project. Next slide. So let me give you a demo of the SkinLens application. Next slide. Hello everyone. This is the demo of SkinLens application. Both unauthenticated and authenticated users can take a test, and based on their authentication, there are few routes that are protected and few that are not. And there is two different roles. One is for patient and one is for dermatologist. Now, without logging in, let's take a look at the home page. On the top, there is a navigation bar with the SkinLens written on the top left corner. That is, when you click on it, it takes you to the home page, and we have a upload button. When you click on it, it takes you to an upload image page, and when you click on records, it asks you to log in to access this feature. And when you click on info, it shows it gives a comprehensive list of all the diseases that are identified by SkinLens. That is, SkinLens can identify a range of skin conditions. It's around 21 diseases can be identified by SkinLens with an accuracy of more than 80%. A few of the most common diseases that are recognized are acne, eczema, melanoma, and you can see the list goes on. So when a guest user or an authenticated user visits the website, just to get an info on what type of diseases are identified by the SkinLens, they can just click on the info page and take a look at all the diseases that are identified by the SkinLens. Now click on SkinLens icon. It takes you to an home page, and on the home page you can see right at the center there is take your skin test now. SkinLens uses AI to analyze skin conditions, detect issues, and provide personalized recommendations. And then you have a start your test button. It takes you same as you click on upload button. It takes you to upload image page, and click on start your test. It takes you to the same upload image page button. Now, at the bottom of the page, you see how it works. The first step is upload image. Take a clear photo of your skin concern and securely upload it. And then second is AI analysis. Our advanced deep learning model analyze the image uploaded by the patient and identify potential skin condition. And third is to get a result. Now, as a guest user, let's start up. Let's take a test. Now, click on the upload button, it takes you to an upload your skin image page, and on the right side of the page you see instructions on how to upload an image. The first is ensure the image is clear and well lit, focus on specific skin area you want to analyze, and the most important is the file formats accepted, that is JPEG and PNG. Now once at the left side of the screen you see select an image button. A user can drag or drop or click on select image and select an image from their local system to upload an image. Let's click on select image button. Let's select a format that is not supported, that is a GIF extension format. Yeah, it gives an error. Unsupported file format. Please upload a JPEG or PNG image. Now let's upload a valid format. So let's select this image. And once the user selects an image, a preview of the image is displayed right here. And so that user can know that they uploaded the right image, and click on upload image. Yep, and as you click on upload image, there's a success message that image is uploaded successfully. And for a guest user to maintain their privacy, what SkinLens does is after 5 minutes, it deletes the image for a guest user. It deletes the image from our database. And as soon as we click on upload image, we get a predict diagnosis button here. And the instructions are on the right side are hidden to make UI more convenient to the users. And then click on predict diagnosis. Clicking on predicted diagnosis gives us a prediction result card with the predicted disease acne as displayed here. And on the right side it tells you log in to view detailed diagnosis description and treatment recommendations. And there is a retake test button on the bottom of the prediction card, and when the user clicks on retake test it directs you to the upload image page. Now let's sign up. Now, when by clicking on the sign up button in the top navigation bar, it redirects you to a sign up page, and it asks few basic questions like a name. Let's create a new demo patient account first, and email as and here's a drop down menu to select whether a user wants to be a patient or is a dermatologist. Click on patient and click on sign up. Now clicking on sign up redirects you to the home page, and as you can see, we have entered name demo patient, and it is visible on the top right corner in the navigation bar. Click on log out. It logs out with a success message. Let's log in. By clicking on login, it takes you to a login page. You can just log in by entering email ID and password. And all the errors and success messages are handled gracefully so that user can know what mistake they are making. Logs in successfully and redirects you to a home page. Now, is this for a guest user? You don't see a chat option available here, and when click on records button, it tells you to log in. But for a authenticated user, when you click on records, all the records, previous records are displayed on my records dashboard. So for this authenticated user, it's let's upload an image and let's take a test. Similarly, a preview is displayed here, and you can click on upload image, and image uploaded successfully and ready for production success message is displayed. And for guest users, the images are deleted after a certain period of time, but for the authenticated users, images are stored securely in the database. And after uploading the image, you see a predict diagnosis button on the bottom. Click on predict diagnosis, and all the instructions and the preview are hidden, and you see a prediction result card with a preview of the image and the predicted disease, that is uh, disease predicted corresponding to this image is allergic contact dermatitis, and below it it is a retake test button. And on the on the right corner of the page, for guest users, you saw that log in to view description and treatment recommendations. But for authenticated user, our app displays description as well as treatment recommendations on the right side. Now, description corresponding to this image is an itchy red rash caused by skin contact with allergens like metals, cosmetics, or plants. Blisters and swelling may occur. Skin becomes dry and cracked over time. And it also suggests treatment recommendations, that is, identify and avoid the allergen, apply topical corticosteroids, and use emollients to soothe the skin. As well as you can see, a view report button is visible below the treatment recommendations. Now, patients can click on view report and a model is displayed. So this report consists of patient details like patient name, email ID, and the case number, skin 81, so that patient can search their records in the history by the case number and the date and the timestamp, the preview of the uploaded image, and the AI analysis result. That is, it suggests AI suggests characteristics consistent with allergic contact dermatitis, and the description is visible here, and treatment recommendations are visible here, and an option to print the report is also available. You can click on the print button, and using windows.print method, it gives you a printed report. You can save it and have a hard copy as well. And on the right corner of this model, you can see a cross button. Click on it to close it. And let's take 3 to 4 more tests for the same patient so that we can view their record history. Click on retake test. It takes back to upload image page option. Select an image. Let's select another disease. A preview is visible. Image is uploaded successfully, ready for prediction. Click on predict diagnosis button. And similarly, it gives you a prediction result that is corresponding disease melanoma, and a description and recommended treatment recommendations on the right. And you can click on view report. Report is visible. Click. Let's take a test again. Click on select image. Let's select another image. Click on upload image and predict diagnosis. Yep, this is corresponding to the image predicted by the AI model is folliculitis, and similarly description and treatment recommendations are available on the right side. Let's take another test. Click on select image. Click on upload image button. Click on predict diagnosis. And the result predicted is actinic keratosis and Bowen's disease. Now we have taken few tests as this demo patient user. Now to view past records, you can click on records button on the navigation bar, and it takes you to my records dashboard, which has all the past cases initiated by this particular user. And you're on the it's displayed in a tabular format. On in the first column you see case ID, that is it's in a format of skin and an incremental number, that is skin 81, 82, 83, 84, and the date and timestamp, and the diagnosis predicted by the model, and the status as pending review, and actions. In the actions you can view the report. Now, the status is pending review here. It means that none of the dermatologist has viewed the report yet. As well as you have a pagination feature here, that is you can click on previous and next, and if the number of cases by a particular users are more, then it is displayed in a good format. And the records can be sorted by date, and they can be by reviewed. There are no cases that are reviewed yet. All of the cases are pending review, so we don't see any of the records here. Open, there are no open cases. There are 4 pending review cases. Now sort by date, right now it's in ascending order. You click on it, it changes to descending order. No, for this, let's log out. Now let's create a dermatologist account for this particular demo. Let's sign up. Demo and select role as dermatologist, and clicking on sign up, it redirects you to a demo dermatologist dashboard. And you can see here, hello demo dermatologist, and on the navigation bar, dermatologists don't see an upload image page, but they still can see info, reports, and chat. Now, reports, this is a dermatologist dashboard which contains all the cases generated by all of the patients, and it's displayed in a tabular format, that is skin number, skin and incremental number, and patient name with their email ID, with date, with the diagnosis corresponding to it, and the status and actions. In actions, you have two buttons, that is view report and take action. Click on view report. This is for the demo patient we just created at the last. So let's take a action. Click on take action. Now, clicking on take action opens a model here, and it says dermatologist review on the top, and case details are visible here. That is the diagnosis predicted by the model, description, treatment recommendations, and at the bottom, you can see add comment. Enter your professional diagnosis placeholder. So let's write correctly diagnosed and click on submit review, and the review is submitted, and automatically the status changes to reviewed, and click on view report. Now after clicking on the view report, after dermatologist updates the puts a comment, you can see in the report a dermatologist review section is added with the comment and reviewed on, as well as reviewed by, that is the dermatologist name. Because in SkinLens there is also an option for patients and dermatologists to chat in real time. That's why it is important for a patient to know which dermatologist reviewed their report, so that they can initiate a chat with that particular dermatologist. Click on close button. Now this dermatologist dashboard contains cases generated by all of the previous users. So we can see there is a pagination feature here, that is page 1 of 14 and two buttons, previous and next. Click on next, it takes page 2, page 3, page 4, and clicking on previous, you can get back to previous pages. Now we can sort out by patient name. Now let's select patient name here, and I have already created a user by name MDZ. And you can see all the cases generated by MDZ are visible here. Now you can also, let's search for our demo patient as, yeah, we can add demo, and we can see all the cases generated by our demo patient. You can also sort them out by patient email. Let's sort them out by, you see, as you can notice, all the cases generated by zakhtar313@gmail.com is visible here with the statuses and all the options. And as well as a dermatologist can know which particular diagnosis is on the trend, or basically what is the common diagnosis that the patients are facing at one particular time, and they can filter out the results by diagnosis. Let's click on acne. Yep, you see all the patients that has acne are visible here. And also you can search by case ID. Now when a person in a chat mentions to the dermatologist that their particular cases is, for example, skin 81, that's the case we generated by demo patient account, and dermatologist can quickly search it and go through it and give recommendations or any additional comments, or answer the questions in the chat with the patient. Now click on SkinLens icon, it takes back you to the dermatologist dashboard. Now let's take an action and let's write one more comment. Click on submit review, and the status changes to reviewed. Now let's log out and log in back as our demo patient. Now you can click on record button to view all the past records, and you can see the status. The two status are changed to reviewed for skin 83 and 84 that we just reviewed as a demo dermatologist. Now you can see the sorting options that reviewed. Yes, then all the status patient can know which of their cases are open or which of the cases are closed. That is, which is pending review and which of the cases are already reviewed. And for reviewed, if they click on view report, they can see the dermatologist review section added here. It's added in a different color so that the focus is on the dermatologist review. It stands out basically. And you can sort it by date, you see, and pending reviews as well as the pagination feature is here. Now let's click on chat. Now when a patient clicks on a chat button in the navigation bar, it takes the patient to chat with dermatologist button, chat with dermatologist page, and a list of all the dermatologists available on the platform is visible. And for example, now in the records, this particular case, that is skin 83, is reviewed. Patient can click on view report and they can see it is reviewed by demo dermatologist. Now if they have any further questions, they can click on chat and they can see this particular dermatologist viewed their case. So they can click on chat to initiate a chat with demo dermatologist, and clicking on chat button, it takes you to a simple chat UI where you can write in text or upload an image or send an emoji. To we added even emoji picker because it makes conversation more and more interactive, and patient and dermatologist can have a conversation freely. Let's send a message. Yep, I sent a message hi, and a timestamp is visible with a single tick. That means it is sent but not yet delivered. Let's send an image as well. Let's send this image. A preview is also visible. You can send, and let's send an emoji. And let's say, let's text, please review. Click on send. Now we have sent 4 messages to demo dermatologist. Let's log in. The website is responsive as well. As you can see, the hamburger icon and everything is works smoothly. Let's log in as demo dermatologist. And you can see the password as well. Click on login. It directs you to a dermatologist dashboard, and they can click on chat. When dermatologist clicks on a chat, they can see a list of all the patients that are available, so that even dermatologists, if they have any special concern related to the case, that is, if for some particular case an urgent care is needed, they can immediately contact the patient and let them know. So let's see where demo patient is. You see, the patient we created for this particular demo is visible here, and you can see notification in the right corner of this card, that you can see four messages. You can click on chat. Yeah, click on chat. You can see the messages sent by the demo patient, and you can see the ticks changed to two ticks and the color changed to blue. That is, it means delivered as well as read by the user. Now, patient, the name of the patient, the name of the patient is visible here, and the name of dermatologist is viewed here, so that the patient and dermatologist both can know that they are in contact with the right individual. Now, patients and dermatologists both can have a chat in real time. Let's see a few examples. Rashes, click send, and you see in real time it's updated here. Let's similarly send a message from patient dashboard. Yep, in real time it's updated. And this is a dermatologist dashboard, and if they this is a patient dashboard which was they were having a conversation with dermatologist, and to get, if suppose they are not satisfied with this particular dermatologist and they want to they want to have a conversation with another dermatologist, they can just click on the arrow here and get back. It takes you back to chat with dermatologist button, and can initiate chat with any other dermatologist. Now we the patient ended the session with demo dermatologist, but when they click on chat button again, they still can view their history, as it is very necessary feature. Because for example, patient had a conversation with the dermatologist, and after a week or few they had to refer back to what the dermatologist recommended, or what were his or her suggestions. They can they can log in again, and they can visit the chat dashboard and view the history of the messages. And as well as this is info, click on SkinLens and takes you back to the start your test button. Thank you. Thank you, everyone.
Thank you.
Thank you
Thank
so
you.
much.
Thank you.
Bye.
Thank you. Thank you for you guys.